Today we're streaming our video presentation, which is going to be a little different for us. But I'd like to welcome today Lee Dumond, who's kind of a man of my own heart in some respects. We're kind of a similar age. I'm older. We both did things besides programming years ago and just kind of evolved into it over time. And you know what? Still likes the technology. He does and I do. So there must be something wrong with us, really seriously wrong. But it's an opportunity for us to kind of share some things and have fun tonight. Lee's going to be talking about the Microsoft Fakes framework. And I do want you to notice when you see the first slide that the date is wrong. Okay. February 4th was going to be the original presentation. This is not February 4th. If you're streaming, this should be obvious. And when you do the playback, you won't care. But just in case you want to know, it is now in March. And it's a little bit warmer today. I do want to thank Cap Strategies for the facilities here, LRS for the audiovisual equipment, also Premier Audio Video for help with the streaming today. And this is the first time we're doing the streaming that I know of. And then also this social media, I'm a little bit of a Luddite. We are on YouTube.com, SVNUG, and if you're seeing the streaming, you know about it. Also Facebook.com, SVNUG, and Twitter.com, SVNUG. So I would like to have you give a nice warm welcome to.
All right. Thank you, Mark. As Mark mentioned, today is not February 4th. We have a whole, Right, we have a whole room full of computers and no way to change that for some reason. I don't know why, but, well, actually I do know why. It's because I'm using a Mac here. So there you go. If you have to run Windows, accept no substitutes. Absolutely best way to do it. And, but I only have PowerPoint Viewer on this thing, so that's the thing. Otherwise, I could have changed it on the fly. So anyway, as Mark said, my name is Lee Dumond. I work for Capital Strategies, currently employed at the Department of Insurance. Not enslaved, they pay me. And I just want you to know before I start that I hate when these things go over an hour. I really do. So I've timed this, and it should be under an hour. In fact, it should be well under an hour. And if it's not, I'm going to kill myself. No, I'm not going to do that. But I will stop talking exactly at 8, even if it's in the middle of a sentence. Yes, then Mark can take over and go from there. So anyway, let's get started. This evening I'll be talking about the Microsoft Fakes framework. What? Oh, okay, yeah. No, that's it. Microsoft Fakes framework, and which is a system that allows you to create test doubles in order to make unit testing your code better and easier. And it can serve as a replacement for mocking frameworks like RhinoMox or MockQ that you might be familiar with already. But as you'll soon learn, the Microsoft Fakes framework is not a mocking framework per se. Although it provides much of the same functionality as mocks do, the Microsoft Fakes framework uses a kind of a test double called a stub. And stubs and mocks can both serve as test doubles, but the approach is quite different, as we'll get into a little bit later on. And in addition, the Microsoft Fakes framework can pull off a few interesting tricks that no traditional mocking framework can do at all. So, and if we have time, we'll get into that as well. But before we get into some depth of the Microsoft Fakes framework specifically, we'll look into unit testing in general. First, we'll discuss why we should create unit tests in the first place. And then next, we'll examine some of the impediments to unit testing that developers frequently encounter. And then how we can refactor our code to make it easier to test. We'll examine 3 different approaches to creating test doubles, along with the advantages and disadvantages of each approach. And finally, we'll see the Microsoft Fakes framework in action, as we'll take a poorly written test and we'll make it faster and better by stubbing out our dependencies. And then we'll conclude with a brief discussion about Shims and why and how they're used, and how the Microsoft Fakes framework makes it possible to use Shims to test legacy code. So why do we unit test? First, unit tests are like safety nets for your code. They let you refactor without fear. If you have a good amount of your code under test, you can refactor, run the tests, so that if they all still pass, you can be pretty confident that you haven't broken anything. Unit tests encourage good design principles. And in fact, there's an adage, and I fully believe this, that even if you do not unit test, even if you don't practice TDD, test-driven development, at all, you should still make your code testable. Because testable code is well-written code. It's decoupled. And so therefore, unit tests encourage good design principles. Unit tests prevent over-engineering. And the reason that is because the rules of TDD state that the first thing you do is to write a failing test. And then the second thing you do is to write just enough code to make the test pass. Therefore, unit tests kind of tell you when you're done, right? I made my test pass, I can stop. Fourth, unit tests serve as a font of living documentation. If, and we'll see this a little later on in the demo, but one of the rules of unit testing is to name the test such that the name makes it obvious what the test does or what the test is testing. And so the idea is if you have a whole suite of tests and you collapse all the implementations and just read the titles, you'll have a really, really good idea of what that code is intended to do. For example, if you have a patient registration application for a hospital, and one of the tests says, registering new patient saves the patient. Well, what do you think should happen when you register a new patient? Should save it, right? That makes it pretty obvious. And if you name your test in that fashion, then it serves as a good source of documentation. And since the test changes as the code changes, or the tests are written as the code is written, it stays up to date automatically. And finally, it's easier to reuse code if it's supported by tests. There's a lot of course, one of the benefits of object-oriented programming is code reuse. And a lot of times we want to use a library that we used over here, but we might have to change some things, add some things, refactor some things that might not be exactly suited. If your code is under test and you move the tests along with the code, then again, you have confidence that if you have to do anything to that library, that it's still going to work. Let's take a look at some of the impediments to unit testing. First, as I just mentioned, the first thing you do is write a failing test. And that seems counterintuitive to a lot of people, right? We're taught all our lives, our whole careers, that we should write good code. We should write code that runs. We should write code that compiles. We should write code that works. And the first thing you do when you write a unit test is you write code that doesn't work. In fact, it often doesn't even compile. To a lot of people, that takes it takes a little bit of a different approach, or it takes a little bit of rethinking to kind of get into it. Second of all, resistance to buy-in. If you test, but nobody else on your team does, it doesn't do you a whole lot of good because you won't have the coverage, okay? Your code will be under test, but if their code isn't under test, then really all that is an exercise in futility. And so if you're working on a project of 2 or more developers, you really need to get everybody involved in unit testing. Third, many people operate under the fallacy, and it is a fallacy, that unit tests require twice as much code and therefore will take twice as much time. that may appear true when you're first learning unit testing, because what happens is, by necessity, the code under test is very, very simple. And that's because the people who are writing these tutorials want to emphasize the testing, not the code under test. And so often, the test code is longer than the actual code that you're testing. But again, that's only in these examples. In real life, that's usually not the case. And I can tell you 100% of the time that I've employed unit testing, the time invested has always paid off in the long run. In reduced time, fixing bugs, finding bugs at the end. So fourth, difficulty in writing tests. Unit tests should be easy to write. Unit tests are very difficult to write if the code is poorly factored, right? If the code isn't written to be testable, then, and we've all had this happen too, you have to jump through hoops sometimes and bend over backwards to put it under test. If that's the case, more than likely you're doing it wrong. Go back and start over. Tests should be easy to write. And probably the most important barrier to unit testing are dependencies. And in this case, we mean classes that depend on other classes or concrete implementations of other classes, especially those that call methods that involve hitting a data store or network latency of some kind. Those can really slow down your tests. So here we have an example of a dependency, okay? We have a patient registration service, and we have a method called register new patient, and it takes a patient object. And what we do is we do some work here, and I'm not going to show that. And then at the end, we save. And to do that, we new up a patient repository, and then we call the save method on it. Now, this is a dependency because the patient registration service depends on a concrete implementation of the patient repository in order to work. And of course, if you had several methods that used the patient repository, which you probably would, you might new this up in a field at the top of the class. But that wouldn't make any difference. You still have this dependency. So how do we fix this problem? We turn the problem on its head, right? This is a screenshot from Uncle Bob, Robert C. Martin's famous blog post, Principles of Object-Oriented Design. I wish I had the date here, I don't, that he wrote this, but it's several years old now. And you'll see this table, if you look at the first letters, SOLID, this is a table that summarizes the so-called solid principles of object-oriented design. And the D in solid is the dependency inversion principle. And it states depend on abstractions, not on concretions. That means no class should depend on a concrete implementation of another class. It should always depend on an abstraction. And in C#, that's an abstract class or usually an interface. So let's take a look at what this would look like in C#. Here we've refactored the patient registration service. And what we have here is we have a field that's of type I patient repository. Now that's an interface. And what we do is in the constructor, we pass in an I patient repository and we initialize that field. And then when we call register new patient, we call it on the interface, okay? The beauty of using something like this, okay, dependency inversion, is that you can provide different implementations of the interface depending on the environment you're in, right? So once you've refactored your classes in this way, you can use dependency injection, which is not the same as dependency inversion, okay? A lot of people use those terms interchangeably. But you can use a dependency injection to provide the concretions at runtime. For example, some kind of a library like Ninject or Microsoft Unity, okay? And you can do that at runtime. And then at test time, you can provide alternate implementations using a stub or a mock, okay, what we call a test double. There are essentially three types of test doubles. There are stubs, there are mocks, and there are shims. And shims are sometimes called moles. I'm not really sure of the derivation of the term moles, but I think that the Microsoft Fakes framework was originally called, the project was originally called Microsoft Moles and Fakes. And I think they used to call what they call shims moles, but you'll hear them called shims most of the time. Really serve a much different purpose than stubs or mocks do. And they really aren't a true substitute for a stub or a mock. If you write your code to be testable, then you should never have to use a shim. But if for some reason you can't refactor something because it's a third-party component or a library that you can't touch, then shims can really be a lifesaver when trying to put that code under test. Just to be clear, the Microsoft Fakes framework does stubs and it does shims. It does not do mocks. If you wanted to use mocks instead of stubs, you'd have to use a library like MockU or Rhino Mocks. And whether or not you prefer stubs or mocks is really a matter of preference. So let's talk about what makes a good unit test. First of all, a good unit test is atomic. That means it tests one thing in isolation. It doesn't bring in concretions of dependencies, because then you're not only testing the code that you want to test, you're testing the dependency, okay? Use the example that we used a little earlier, registering the patient saves the patient. All we really care about is whether or not the save method was called. We don't really care about whether the save method works. Well, let me stop. We care if the save method works, okay? But that's a different test, right? We should definitely test that logic, but in a different place, not together. A good unit test is deterministic. It either passes or fails. A good unit test is never inconclusive. There is no maybe in unit testing. There's no close enough. It's either yes or no, black or white, 1 or 0, pass or fail. A good unit test is repeatable. As long as you never change the code under test, the result should always be the same every time. It shouldn't fail sometimes and pass sometimes for no apparent reason. It's order independent, and what that means, if you see on Stack Exchange once in a while, somebody asking a question, how do I make my test run in a certain order? If you find that you need to have your test run in a certain order, again, you're doing it wrong. To be not order independent means that the results of one test rely on the running of another test, and that should never happen. A good unit test is fast, and when we say fast, we're talking about on the order of fractions of a second. Seconds is entirely too long for a unit test. Even 1 second. Let's just say a moderately sized MVC application, 1,000 unit tests would not be out of the question. Well, at 1 second each, 1,000 tests take 17 minutes to run. No one's going to run a test suite that takes 17 minutes to run. And a test should be easy to set up. Everybody in this room is a developer for one reason. Because we love computers and technology? No, because we're profoundly lazy, okay? At least that's why I got into it. And because I am so profoundly lazy. If a unit test is not easy to write, then I'm not going to write it. So a unit test should be easy to set up and easy to write. So let's take a look at some code, some poorly written tests, and improve it using the Microsoft Fakes framework, and you'll kind of get a chance to see how it works. So let me do that at this point. Why did this go back to the beginning? Because hold on a second. Okay, let me just, all right. So right here we have something that's open here, and this is a patient registration service, again, like you might find in a hospital. And we have a domain, we have a patient object, and it's pretty simple. It just says an ID, a first name, and a last name, okay? What? Can I make the code bigger? I could. Okay. All right. Of course, I'll have to do that for every page probably. So, all right. So we have a patient class, and we have a patient registration service. Let me take care of that one. Okay. And you see here, just like we showed in the slide, that the patient registration service has a dependency on the patient repository. And here we have a patient registration service tests. And is there a shortcut to Zoom? Is it Control Plus or something? Yeah. Okay. Not on a Mac, it's not. All right. So, okay, that's plenty big enough, right? So we have a registration service test, and this test is called Register New Patient Saves the Patient. So what we're doing here is we're newing up a patient registration service. We're newing up a new patient with an ID of 123, first name Lee, last name Dumond, okay? And we're registering a new patient using the registration service that we newed up. And then we get a instance of the patient repository. And the patient repository, I didn't show you this, but it essentially has two methods. It has a save method and has a get by ID method. That's not really important, but anyway. So I'm using the patient repository, getting by ID, ID 123, which is what I inserted up here. And then what I'm going to do is I'm going to assert that the IDs are equal, the first name is equal, and the last name is equal between the one that I inserted and the one that I retrieved, okay? So let's go ahead and take a look at this. I shouldn't have, hold on a second. I shouldn't have scratched my hair because it made the trackpad wet, okay. All right, so we'll run this test. Now, let's take a look at this and ask ourselves, was this a good unit test? Well, was it atomic? No, because of the dependency that was left in. We still have a dependency on the patient repository. It wasn't deterministic because we're using the actual patient repository. That means it's actually connecting to a real resource, right? Maybe it could be, it doesn't really matter, but it could be a database, it could be a network file server, it could be a cloud service. We don't know and we don't care. But it depends on that resource, and that resource might be available. And if it is, then the test will pass, and if it's not, the test will fail. So that's not deterministic at all. Is it repeatable? Well, let's go back and look at it. You'll see that I'm using an ID here, okay? And we're not exactly sure, but presumably that would be some kind of an identifier, a unique identifier, okay? So the first time we run this test and we insert a record of patient with an ID of 123, that might work fine. And what might happen the second time we try to run this test? Right. We might get a unique constraint exception of some kind, right? So that's not repeatable at all. It might not be order independent either because of the fact that, because we only have one test here, but the fact that this is hitting data store means that something that happens in a previous test could affect the result of this test. I'm going to run it one more time because I forgot to look at something. Okay, the test took 6 seconds. That's vastly too long. It should be about 50 times faster than that. So, and was it easy to set up? Well, this wasn't incredibly difficult to set up, but that's really only because the code under test is very simple, and the patient object is very simple, only has 3 properties. But you see, we have this whole string of asserts here, and if we had more properties, we'd have to have more asserts, and that would get pretty code smelly and messy pretty fast. So there's a couple of things we can do here. The first thing we could do is we could factor out this dependency Of course, we don't have an iPatient repository yet. Okay, so let's go up here and make one. Okay, so now we have an iPatient repository that has get by ID and save. And so there we go. And let's initialize that in the constructor so that we'll be able to use dependency injection later. And then, okay, so now what we've done is we've refactored this method in order to extract the dependency on the concrete class. And now what we're depending on is an abstraction, which is what we wanted, okay? And so what we want to be able to do in the test is to provide a stub for this iPatient repository. You'll see that this doesn't compile anymore because it requires an iPatient repository here in the constructor. So the iPatient repository is in the data project. So what we're going to do in our test is we're going to go to the data reference, and we're going to right-click and go Add Fakes Assembly. So what happens is now we have a new assembly called Data Fakes, okay? And what has happened is this has stubbed out all the interfaces and objects and methods in that project. So now, let's go ahead and okay. Well, at least now the code compiles, okay? But it's not really testing anything yet because we haven't stubbed out the method that's in this stub. There's a default implementation that's created when we call the method, okay? Remember, stubs return real values, and the return value on the save method was void, so it's not going to return anything. So how do we use it? Well, remember, we don't want to test the saving, right? What do we really care about? We just care about whether or not the save method was called, okay? When you're using mocks, that's very easy to do, but when you're using stubs, the way we do that is this. We can just set a bit up here. We'll call it save was called, and we'll initialize it to false, okay? And then what we'll do, and this is kind of a weird thing that this does, quite frankly. You'll remember in the stub patient patient repository, the method was called save, and it took a patient object. So what happens is when it generates the stub for that method, it takes the name of the method and the name of the type that you insert. So it's save patient. Okay. I don't know why it's not just called save, but it's called save patient. And you'll notice that save patient is an action. So that means it takes a delegate. So we can just override the default implementation of this action by specifying a new delegate. So what we'll do is we'll say equals okay. So what we're doing is we're saying, look, in the stub repository, if this method is called, take this field that you initially set to false, or this variable, and set it to true. And so now let's just get rid of all of this down here. Okay. So another thing about Macs, no backspace key. So, and now all we have to do here is, we don't need this either. All we have to do here is assert is true, save was called. So, go ahead and take a look at this. What happens is we have the new stub patient repository. We say if this is called, set this variable to true. We'll go ahead and insert it into the constructor. We'll new up a patient, we'll save it, and then we'll see if it was called. So let's do that. All right, and this test took 0.105 seconds, okay? That's a damn sight quicker than 6 seconds. All right, so let's ask these same questions. Was this a good unit test? Well, it was atomic because we didn't test the saving. We only tested that save was called, which was the one thing that we cared about. It was deterministic because it no longer depends on resources which may or may not be available. It's repeatable. This test will always have the same result, again, because we don't depend on anything external. It's order independent. This does not depend on the results of any other test, and no other test would depend on the results of this test. It was very fast, took only about a tenth of a second, and it was easy to set up. So let's take a look at another demonstration here. Do a little song and dance while this is loading. I didn't. Huh? Awful fast on that Mac. Yeah, I know. Well, okay, here we go. It's running boot camp, so. All right. So now what we're doing here is we have essentially the same code, but the patient registration service is doing a little bit more heavy lifting. What we're doing here is we're actually validating the patient before we save it. So we're registering a patient, and it presumably would be doing that up in here somewhere. And then it finds out if the patient is valid by calling validate on the patient validator. And if it's valid, then we save it. And if it's not, we throw an exception, okay? So, and you'll see that there's an I patient validator, and those are both input into the constructor. This is already set up for dependency inversion. The patient validator is actually very simple. All it does is check if the first name is not null and the last name is not null. If either, what?
Quick interruption. A lot of times people can start out with everything with the interface. They say, oh, we got to make the patient with an I-patient interface.
Right.
And so what happens is they make everything too decoupled when it's kind of silly.
Yeah. Right. You should have a reason. The bottom.
Certain things you don't want to necessarily make with an abstraction, like a poco kind of.
Right. Yeah, you don't have to abstract everything. You know, I rarely abstract like my domain objects, you know. Yeah, exactly. I mean, I understand your point. I mean, yeah, you should always have a reason to use an abstraction, sure. Otherwise, then you're just, you know, what do the British call it, wanking? Okay, so anyway, anyway, what I was saying was the patient validator just checks if the first name is null and the last name is null, and if they're both not null, then it calls it valid. So we have a couple of tests now. We have a register new patient saves the patient if patient is valid. And then we have a register new patient throws argument exception if patient is invalid. And you'll notice up here, this is very much the same test that we just saw. All we're doing here is we're just throwing in a patient validator to get this to compile. And down here, when we test if the patient is invalid, what we're doing is we're actually using a try-catch block. We're throwing in an invalid patient because first name is null, right? That means that the patient would be invalid. And so what we want to happen here is we want, when this register new patient method is called, we want it to throw, skip over this assert fail, end up in this catch, and then assert is instance of argument exception. That means the test passes. So let's go ahead and run this. And this should run fine, hopefully. Okay, so it ran. But still, we have a dependency on this patient validator, right? And the problem is, this should not depend on the logic in the patient validator. It could be faulty. We should test it, but not here, right? So let's go ahead and stub out the patient validator. Now, the patient validator is in the services project. Now, you remember last time we created a fakes assembly for the data project. Now, we can go back in here, we can go to services, we can do exactly the same thing. We can add a fakes assembly. And so now we're ready to stub out our patient validator. So what I'm going to do here is I'm going to and you'll remember that the method that we want to provide a delegate for it was called validate, and it took a patient, so it's going to be called validate patient, I bet, right? Yeah, there you go, validate patient. And what do we want to happen? We're testing in this first test what happens if the patient is valid, right? So what we'll do is we'll just have that take a patient and let's see, we'll just have it return true. Okay, so now we can take the stub patient validator and stick it in here. And then we'll go ahead and run this test. And there you go, it runs fine, passes. But now this no longer depends on a concrete implementation of the patient validator. So even if the patient validator would somehow have some kind of a faulty logic and return true for an invalid patient, that doesn't matter to us because we stubbed it out. Just want to check my time. Okay. So now let's do the same thing down here, okay? Now what we could do is we could actually take this right here and just put it down here. And that's all we would have to do. Oops, no, that isn't all we'd have to do because now we're testing if the patient is invalid. So now we want it to return false, right? When we call validate patient, we want it to return false because we want to simulate the invalidity of a patient. So in order to make the test make sense, in order to make it readable, we can definitely provide this delegate, okay? But the thing that I want to point out is that when, and I mentioned this before, the default behavior is it always returns when it first generates the stubs, the default of whatever the return value is. In other words, if a method returns void, it returns void. Because stubs always return real values. If a method returns an integer, by default it'll return 0, unless you, again, override the delegate. If, in this case, if it returns, this is a func patient bool, so this would return a Boolean, so it would return false even if we did nothing. So let's go ahead and just take, we can just take this out if we wanted to. Again, that's the default behavior, and that can be overridden. I won't show you how to do that right now. I don't have time. But we can just go ahead and run this test, and we'll see that it runs successfully. Okay. Now let's take a few minutes to talk about shims. Again, as I mentioned before, shims really serve a much different purpose than a stub or a mock. And they aren't really a substitute in the true sense for a stub or a mock. And that's because, really mainly because, unlike stubs or mocks, a shim does not force you to write good, solid, testable code. Shims let you test some pretty gnarly and nasty stuff. Okay? Let's take a look at when you might want to use a stub and when you might need to use a shim. Here we have a patient registration service that's all nicely factored out, relying on an abstraction. And in this case, can I factor out my dependencies? Yes. Use a stub. Or mock, if you're using a mock framework. If for some reason you cannot, then that's when you'd use a shim. And why might that be? For example, let's just say we need to test legacy code that for some reason or another we can't factor away the dependency. It's a black box. We can't touch it. It's somebody else's library. Our boss won't let us refactor it. Who knows? Before I show you this, what I'm about to show you, I just want to make it very clear, okay, that shims are not designed to be permanent fixtures in your code. And again, that's because shims are dangerous. They allow bad design. It's really like, a shim is really like a temporary fix, like in real life. Everybody knows what a shim is in real life, right? Let's just say I'm a carpenter and I build a table. And the table wobbles. And I shove a book under the short leg. That book is a shim, right? What did I do? I stopped the wobbling, but I didn't fix the table. It's still poorly designed. In order to really fix it, I need to redesign and rebuild the table. And then take the book out, take the shim out. And that's what you really need to do with your code too. Use a shim if you have to, but under all circumstances, if possible, refactor the code and take the shim out. So let's take a look at how shims work. Am I still good for time? Oh, we got 13 minutes. I'm still good. Okay. I factored all this time in. Okay. So anyway, this actually is exactly the same thing that we saw the very first time we saw this code. This is the original code that I opened the first time. And since you've all seen it before, we don't have to make it bigger this time, do we? Okay. So, but I'll make this one bigger because we're going to do some work in here. So, all right. So let's go ahead and run this. I predict what will happen this time is the same thing that happened last time. It'll take about 6 seconds, I think. All right, yep, about 6 seconds. Of course, that's entirely unacceptable. And this, again, this is a bad test for all those reasons I already mentioned. Okay, but now we're stuck, right? Oh, why do I keep doing that? I'm making my finger wet and I can't work the trackpad. Okay, here's our patient repository, and this time we cannot make an iPatient repository. This data is a black box. We can't touch it. It's dead to us. So let's see what we can do here. What I'll do first is I want to be able to put some more methods in here. So I'm just going to move this patient repository up. So I should have done this before. Hold on a second. Okay. All right. Is what I've just done, let me make this a little bigger here. Is what I've just done dependency inversion? Absolutely not. This is not dependency inversion, okay? All I've done is just moved where I'm doing up this patient repository. But it still depends on an actual concrete implementation of the patient repository to pass into the patient registration service, right? So I haven't inverted anything. But of course now my tests are not going to work because I need this. So let me just shove in a new patient repository. And if I run this again, yeah, it still takes 6 seconds, of course. Like I say, I haven't done anything. All I've done is just change where I'm doing up this patient repository. So, at this point, we're stuck. We're stuck now. There's nothing we can do, right? Right? Wrong. Okay, and I'll show you why. First of all, let's get rid of this. And let's get rid of all of this. All right. We still want our bit variable here. So we can test if it was called. And at this point, we can use a shim. So the important part of using a shim is to remember that all the acting has to be done inside of a context. Now, I didn't talk about arrange, act, and assert, but if you know what that means you arrange the tests at the top, you put the assertions at the bottom, and in the middle is where you do all the fancy stuff, right? And so the acting part all has to take place within a shim context. So that's what I'll do right here. Shim's context, is that what that says? Okay. Create. All right, so then in here, I'll make a shim patient repository equals new shim. Why is this? There we go. And we'll just do what we did before in terms of providing a delegate for the save patient method. We'll just say save was called equals true. Okay. Now we still have to remain inside.
Hey, Lee,
Yeah?
I got a question for you.
Yeah?
Where is Shim Patient Repository defined? How did that come to be?
Oh, I didn't do it again, but we have this, data fakes. Remember what we do is when we right click on a reference, right? We go add fakes assembly. It adds an assembly, this data fakes. And what happens is it generates that assembly. And what happens is it creates stubs and shims for everything in that project. So I had already done that before. And so that means that we have the shim patient repository available.
Thanks. Does it do only public members, or does it do all classes in the?
Does everything.
Does everything in the
Yeah.
assembly?
Yeah. You can. I can get into this a little bit later if you want, but there's an actual right down here. There's an XML file that you can use to configure how the stubs are generated. By default, it stubs everything. It stubs concrete classes. It stubs interfaces. To me, there's no point in stubbing concrete classes. I don't even know why you'd want to do that. So what you can do, for example, is you can say, stub generation, and you can say clear, and then you can say, oops, and then you can say add interfaces equals true. So now this will only stub out interfaces. You'll see all the different types that it can stub. Add, you see, abstract classes, interfaces, based on the namespace, the full name, the type name, all kinds of stuff. Concrete classes. So here, if I do this and then rebuild, it'll only stub out the interfaces. Okay. So anyway, let me just finish up here. So now that I have my shim, now I can do up my new patient registration service. And you'll see that this is asking for a concrete patient repository, not an iPatient repository, a real patient repository. But what I'm going to do is I'm going to give it the shim patient repository. And then I'll go ahead and just call it on this. Let's see, register new patient, and I have my new patient up there. And okay, so I've done that. And now I can go outside of this and I can do my assert. Assert is true, save was called. All right, and now let me go ahead and run this. And, it failed. Oh, I always forget this. Okay, this is important. I'm glad this actually failed. I'm using the ReSharper test runner. The ReSharper test runner does not have the instrumentation to be able to deal with shims. So if you have shims, you have to run it using the real Microsoft test runner. So let me go ahead and do that. So why is this not showing up? Let me do a rebuild. Okay, it finished, right. All right, and it took 135 milliseconds. I'm just going to run it again real quick. Okay. Again, took 135 milliseconds. Now that is a damn sight quicker than 6 seconds, right? I have 2 more minutes just to show there's nothing under my sleeve, up my sleeve. Okay, here's what I'm going to do. I'm going to go in here and I'm going to actually set a breakpoint inside of here to show that it's not hitting the real patient repository at all. Let's debug all tests. Okay, it's debugging now. All right. Now you'll see that this time it took a little longer to run, 296 milliseconds. That's because of the debugging symbols and all that. But it never hit the breakpoint, right? So that patient registration service absolutely needed a concrete implementation of patient repository, and we were able to test it without doing that, using a shim. So anyway, in conclusion, I just want to say that in this presentation, we learned about how the Microsoft Fakes framework lets you write better, faster unit tests by generating stubs that serve as test doubles to stand in for dependencies at test time. And we also learned that the Microsoft Fakes framework generates shims that can help you put even poorly factored legacy code under test. And I hope that this little talk inspires some of you to give the Microsoft Fakes framework a spin the next time that you need a test doubles framework for your unit testing needs. Thank you very much. And it is exactly 8 o'clock. There you go, right there, buddy. Call me Mr. Timing. Any questions?
Yes.
Okay.
How do we get the Fakes framework? Is it
It comes with Visual Studio 2012 and higher, Ultimate, Premium, or Professional, I think. Yeah.
So if I've got Pro, I've got it right now.
Should. Yeah. I have Ultimate on this machine, so I don't know. Although I do know for a fact that when Visual Studio 2012 came out, it was only in Ultimate. And due to protests, they put it in lower SKUs, and so now it's available in lower SKUs. But I don't think anything less, like it's not in the Express editions or the standard or whatever they have, for sure. Yeah.
So once you're finished testing using your fakes assembly, then is it easy to remove it?
No.
So that, and I'm assuming you don't want to remove it.
Right.
That you want to leave it in there.
You have to leave it in or the
anybody
test will run.
else who modifies your code is going to have to work with it as well.
What do you mean?
Well, in other words, now that you've gotten the thing tested and
Right.
your program runs and you send it out to your users, now when you have other developers working on it, they've got that.
Oh, they've got the tests too. Yeah, sure, right. The tests always live with your project, right? Sure, or else they should, you know. You'll notice that it acts as a little bit weird, like that renaming, you know. Why call it Save Patient? Why not just call it Save? To me, that just makes it, to have the the generated name of the method be a different name than the actual method that you're stubbing, to me, just makes no sense, number one. And number two, I don't know why by default it stubs out concrete classes. That makes no sense to me either. You know that little thing I did where I just cleared it and then just made it so that it only would generate stubs for the interfaces? That's usually the first thing I do so that I don't have to deal with all those, that drop down of all those extra things to deal with. And to me, the other thing too is to remember that when you have a lot of tests, that's a lot of fakes. And a lot of fakes means a lot of extra code that you have to compile every time you build. So it adds to your build time. Of course, you could say that a mocking framework has to generate all the proxies at test time, so that could add to your test run time. I don't really know. I've never really tried that or tested it to be sure. I assume it would a little bit. But to me, I like Rhino Mocks. It's a pretty good framework. I like Type Mock. It's very expensive. And but MockU is free too, as is Rhino Mock, so those are good. But again, it's just a matter of preference. So, and Microsoft Fakes framework is a lot better than it was when it was moles and fakes. So, like all Microsoft things, they kind of get better over time.
So one of the things, I think you mean pecs and moles. Is that what you're talking
Huh?
about? You said fakes and moles.
Yeah.
I think you mean pecs and moles.
Pecs and moles?
Yeah, it was a Microsoft thing they had out. It was called pecs and moles.
Oh, was it?
Yeah.
Oh, okay. I could be. I defer to you on this. I got to plead ignorance on this thing.
One of the things pecs and moles would do is it would allow you to intercept requests to like datetime.now.
Right.
And a couple of those other things.
Yeah.
Can you do that with
Yeah,
this?
you can do that with this, but you can do that with a mocking framework too by just using delegates on your own. If you mocking out things like datetime.now, if you is anybody here heard of Ayende? He's a developer at Israel. Right, exactly. He has a really cool blog post that he wrote a couple of years ago about how to mock out datetime.now using like a little delegate class. That's the first thing I do almost every time if I have to do tests with time. Yeah. So you can do that with a mocking framework. I mean, you can do that with any framework, just you can write your own little stub for that. And I do that, I use the same technique. For example, at work, we have to write intranet applications, and what I want to be able to do is log on as different people, but I can't obviously ask them for their credentials, right? So what I do is in web config, I wrote a little routine that I can have a key that says a person and employee, then I can put just their login ID if I know it. And then I can use the, instead of using the identity.user.name to get their employee ID, I can just use this little, I have a little way of mocking out the employee ID to take it out of the web config and then pull it that way. And so I can kind of pretend to be them, and I can impersonate them on the local machine. And that's actually a little thing that I stole from my NA using the same technique. So anyway, yeah. Anybody else? All right. Thank you.